Okay, in part one of this section, we saw how to find exponential equations when we had a table, and it was really easy to recognize what the A number was and really easy to recognize what the B number was. Reality is it's not always quite that easy. And in general, here's the kind of problems we're going to answer. We're going to be given 2 points, and we're going to want to find the exponential equation. Well, our exponential equation looks like y equals a times b to the x. This one is fairly easy in the sense that we are given the y-intercept. We recognize we have the y-intercept because we have 0, something. That right away tells us the a number. We know a has to be 4. Then what we're going to do, to find the b number, we're going to plug in the other point. So we're going to plug 100 in for y, and we're going to plug 2 in for x, and then we need to solve. And then this comes back to what we were doing at the end of the first video. How do you get that b all by itself? Well, you divide both sides by 4, so you're going to have 25 equals b squared, and then you do the square root of both sides, and normally we would write b as plus or minus 5. Square root of 25 happens to be plus or minus 5, except you got to remember in the previous section our definition of exponential functions, the only b number we pick is the positive one, so b has to be the positive value. All right, so the answer to problem 1 is y equals 4 times 5 to the x. Okay, next one. Again, we have y equals a times b to the x. And again, this is quite nice because right away, without doing any work, we know that a has to be 6. Once again, they're giving us the y-intercept, which means they give us the a value. After that, it works exactly like it did a minute ago. We plug in these numbers, and we see what happens. So we have 2 equals 6 times b cubed. We divide both sides by 6. We get 1/3 equals b cubed, which means b is the cube root of 1/3. And typically what we're going to do here is we're going to approximate. We're going to round it off to 2 decimal places. So let's see, math, cube root of 1/3, 0.69. So the answer to this one would be y equals 6 times 0.69 to the x. So just a few comments on these. For this first one, notice b turned out to be 5. 5 is bigger than 1, so this one would be growth. You know, ask that in the section, but it's always good to recognize that. And this one, our b turns out to be smaller than 1, 0.69. So this one is something that we called decay in a few sections ago. And that seems to make sense because here, when the x number got bigger, the y number got bigger. That tells you growth. On this one, when the x number got bigger, the y number got smaller. So that's an indication of decay. All right, well, sometimes they throw some negative numbers in. That's not really a big deal. Again, right away we know our a number, so I'm just going to write down y equals -3 times b to the x. And then we plug in our other 2 numbers. -81 equals -3 times b to the 4th. Divide both sides by -3. 27 equals b to the 4th, which means b is the 4th root of 27. And again, we would normally do plus or minus, but I'm going to skip the plus or minus because in this section, b can only be a positive number. So I type that into my calculator. Let's see, 4th root of 27 is approximately 2.28. So y for this case would be -3 times 2.28 to the x. So having the negative numbers really didn't change much. It just put a negative out front there. All right, these last 2 are a bit harder. And what's a bit harder about these last two is notice they did not give us the y-intercept. We don't have 0 comma something, 0 comma something. We don't have that anywhere. We don't know the y-intercept. So these are a little bit harder. Here's what we're going to have to do. We're going to write down y equals a times b to the x, just like we always do. And we're going to plug in both the sets of numbers. So I'm going to plug in 2 for x and 5 for y. 5 equals a times b squared. And then I'm going to plug in here 2. I'll have 10 equals a times b cubed. What we end up with is a system of equations. We did this back a few sections ago where we had systems of equations where we have 2 equations that have 2 letters. Here's what we're going to do. We're going to take one of these equations and we're going to get a all by itself. Now the one you usually want to pick, you want to pick the one that has the smaller exponent. So I'm going to use this one. I'm going to take 5 equals a times b squared, and I'm going to divide both sides by b squared. So that gives me a equals 5 over b squared. Again, pick the one with the smaller exponent. What you're going to do is take that and plug it into that equation. So we have 10 equals, instead of a, I write 5 over b squared, and then I multiply that by b cubed. I'm going to think of b cubed as being b cubed over 1, and I can reduce b cubed over b squared. I subtract my exponents. 3 minus 2 is 1. So this turns out to be 5b. And then it's very easy to get the b all by itself. B turns out to be the number 2. Finally, I need to know the a number. To find the a number, I take that b number and I plug it in right there. A is 5/4. Final answer for this one is, I'm going to do this to leave myself some space, y equals 5/4 times 2 to the x. Alright, so you see what we had to do there. We had to create 2 equations and then solve the system by doing a substitution method. We got a all by itself, and then we plugged it in. We're going to have to do the exact same thing for the next problem. Y equals a times b to the x. Plug in our numbers. Well, our numbers are pretty big this time. 492 equals a times b to the 11. And 8 equals a times b to the 17. All right, again, you want to deal with the one that has the smaller power. This is the one that has the smaller power. So I'm going to take this equation and I'm going to divide both sides by b to the 11. 492 over b to the 11 equals a. And then I'm going to take that and I'm going to plug it in right there. 8 equals 492 over b to the 11 times b to the 17. Alright, so you might be asking the question, why did I pick the one that had the smaller b number? The reason is I want the smaller exponent to be down on bottom so that when I simplify these two things I end up with a positive exponent. If I had dealt with the bigger one, then the b to the 17 would be down on bottom and the b to the 11 would be up on top, and then I'd subtract and I'd get a negative exponent, and that would make my life harder. So I'm trying to make my life a little bit easier here. I subtract my exponents, I get 8 equals 492 times b to the 6. Alright, I divide both sides by 8. I'm using my calculator here. 8 divided by 492. And that happens to be 2 over 123 equals b to the 6th. And then I take the 6th root, and again I'm just going to use my calculator here. 6 math, 6th root of 2 over 123. I get 0.50, rounding to 2 decimal places. B is 0.50. Alright, to finish this one off, I take that answer and I plug it in right there to find the a number. So a is 492 divided by 0.5 raised to the 11th. That turns out to be a very big number. 1007616. Final answer. Y equals 1007616 times 0.50 raised to the x. Alright, so you see how those two problems are a little bit harder when you're not given the a number right away. This is the technique you're going to have to use. You're going to have to plug in twice, do a substitution, solve, figure out the b number, and then plug in and find the a number. A little bit challenging, but definitely not anything you can't handle. All right, so that ends this section. Go ahead, work on the homework, do the quizzes. Let me know if you have questions.